Place. Our next presenter is Addison Snell. Addison is the CEO of Intersect360 Research. He is well known to many of the attendees here at the conference for his providing insight into HPC technologies, applications, and the market area itself. Let's welcome Addison to our podium.
Thank you. Let's plug that in here. What are we doing here? Good morning. Is that mic working okay? I'm Addison Snell. I'm with Intersect360 Research. I'm delighted to be at HPCC again. This is really one of my favorite conferences of the year in terms of it being an intimate gathering with some people who are really at the nexus of what's going on in the industry. It's also a fun time of year for us to give a presentation, a look ahead to what some of the most important market trends are for the year. We can start taking an actual look back at how 2011 went and look at 2012 going forward. I've known many of you for many years here. Hopefully people are growing familiar with Intersect360 Research. You might remember us still, a few of you here, as being Tabor Research. We were founded as Tabor Research 5 years ago as a division of Tabor Communications. That's the organization that publishes HPC Wire, Datanami, a few others. My partner, Chris Willett, and I acquired the Tabor Research division almost 3 years ago, and brought it independent as Intersect360 Research. A few of you might also be confused by the radical rebranding that we've undergone. The S in Intersect used to be capitalized and is now lowercase. It always kind of creeped me out because when it was capitalized for no apparent reason, I felt like we were an organization for negotiating between cults. So we've gotten rid of that. It's an important rebranding that we've done since my last presentation here. I think the email with the capital S still works. We've been doing quarterly surveys of the HPC end user community since 2007. 2 of those surveys every year have been on end users' installations, what they have installed, inclusive of the hardware, the software, hardware, the servers, the storage, the interconnects, the processors. Another of these surveys we've done every year has been on budgets, how budgets get divided between categories, on items within categories. And all of that end user research has really gone to trying to provide us with a headlights view of where the market's going, get on top of some of the HPC trends. So while of course we do market sizing, market forecasting, all of that stands on the foundation of end user research. We do feature articles in all of our partner publications. I have a weekly podcast together with Michael Feldman of HPC Wire, who's been here with me in the front row. If you catch the HPC Wire Soundbite podcast, that's a lot of fun. Michael keeps me up to speed on what's going on in the industry every week. I've got to keep up with him. The analyst crossfire panels that we've been running, which were actually originally Rich Bruckner's idea, he's at the other table up front. We've done those at 3 conferences a year now for a little while. We've got another one tomorrow, whereas Bob Feldman's panel has just had an extra half hour added. My panel is a half hour total. It is a fast-paced panel where we'll cover 7 topics in 30 minutes, not including the Q&A. I encourage you to take a look at those. They're a lot of fun for us. And then, of course, a big thing people are increasingly asking me about is our trivia cards. We put those out twice a year. I've got a few sets of them on me now. So example for the room, for the last 3 years, which of these categories has increased as a percentage of HPC spending in every year? Ready? Storage, staffing, facilities, or cloud computing? Which one has gone up as a percent of spending every year? Answer is facilities. Facilities has gone up every year. Storage is on there as a sucker bet. Storage goes up as a percent of hardware, but hardware falls as a percent of spending. So you can see me for your set of trivia cards if you like. I'll drop out of this just to give you one other thing. This here is a PDF of things that we published in 2011, our research reports, special studies that go beyond the basic research, white papers that we do, feature articles that we write in our partner publications, press releases we've put out. The podcasts are really where we react to what's happened that week in the news. We tend to cover 2, maybe 3 stories. And then the bottom is other places where we've been quoted in the news over the course of the year. So dropping into the forecast, first thing I'll say about this is these charts are still based on year-end 2010. We are putting the wraps now on year-end 2011. We've got the first draft of that, and I'll talk to that momentarily, but I don't have charts that are this nice yet. The big obvious thing here is the recession that was in 2009, and then we recovered in 2010. That was 22% growth from 2009 to 2010. A lot of that was sales cycles that got very long during the recession and then came back in 2010. HPC is a long sales cycle item. So those of you who are in HPC sales kind of get the notion that if it used to take you 16 weeks to close a deal and now it takes you 24 weeks to close a deal, you just took 2 months of revenue and dropped it out of this year and into next year. So you get a huge shortfall that then starts coming back. We had been forecasting pretty good growth from 2010 to 2011, but here's a quick note on that. This is one of my favorite quotes, comes from my partner. He told me once, when you create a forecast, it has to be bound by what's realistic, but reality has no such boundaries, right? Reality can do anything. So we put out this forecast, and then a few things happened in 2011 that were outside of our forecasting methodology. We'd originally forecast about 9% growth. That was this from 2010 to 2011 is 9%. We've gone through the first draft of the forecast, and when we eventually put it out, it'll be about 4%. That's maybe plus or minus a percent still as we still fine tune it, but 4% is going to be pretty close. The 2 reasons we fall short of the 9 that weren't in our forecast, one is the Eurozone crisis that expanded the recession from North America now into Europe. We have a lot of survey data that shows that worldwide budgets, HPC budgets for academia and for government in particular, are flat to even declining 2010 into 2011, and the outlook is also poor in the near term for government and academia. Commercial budgets are still within the realm of what we'd normally see, but the government and academia are off. The supercomputer sector is going to be hurt in particular by that. So we've seen that in Europe. The other big thing that happened from a revenue perspective is the flooding in Thailand throughout the second half of the year disrupted the supply chain for storage. And storage is not as big as the server component, but is still significant. Depending on the storage manufacturer, that could really have affected their revenue in Q4 in particular. Q3, a lot of the suppliers were still shipping off of current inventories, but by the time you got into Q4, a lot of deals got pushed out. We even heard some vendors talk about cluster deals on the server side that got pushed out because of the lack of availability of storage. So that's mostly a delay. Stuff falls out of Q4 into Q1 or Q2 of 2012. There's very little effect on the 5-year compound annual growth rate. We're still largely bullish on the industry, but 2011 growth was about 4%. Total market by region for 2010 was the first time we showed North America, which really is a misnomer. That's U.S. and Canada, because Mexico and Central America are part of Latin America. But the first time U.S. and Canada was less than half. EMEA is going to have had a bad year in 2011. Asia Pacific is going to have a strong year. So by the time you see this chart again in a couple of months, that there will be some changes to that. I expect Asia Pacific will be a stronger percentage. Most importantly, with our methodology, we're tracking both what we call high-performance technical computing, which is applications that are in science and engineering usage of HPC, and what we call high-performance business computing, which is non-scientific business applications. The best way to describe this is to look at the pie chart of vertical markets. High-performance tech. So first of all, these pies are drawn the same size for ease of viewing, but they're not actually the same size. The one on the left is about 70% of the market. The one on the right is about 30% of the market. Among high-performance technical computing, there's still a big commercial percentage of that because there are companies that do science and engineering. Manufacturing is the largest group. The 9% here is basically automotive and aerospace. The 4% here that's moved up to be next to it is consumer product manufacturing. So things like Procter & Gamble's the poster child there. Together, manufacturing is 13% of high-performance technical computing. Other major components of commercial on that side include biosciences, energy, chemical engineering, et cetera. Commercial together is 40% there, government 35%, with the primary distinction between security types of applications, which is more production-oriented and acts like commercial, versus the research labs on the other side, which are more research-oriented and tend to act like academic. And then academia is all lumped together as that 25%. On the other side, the high-performance business computing is maybe even the more interesting to look at. People will talk about financial services quite a bit. That's a huge and very fast-growing sector. At this point, it's probably overtaken manufacturing as the #1 commercial sector. It's growing awfully fast. But for now, think of them as about the same size. There's as much HPC revenue in finance as there is in manufacturing. The next biggest chunk here is the most controversial one in our methodology. Some of our clients like to count it, some don't. It's labeled as ultra-scale internet. This is our catch-all for things that don't meet any other definition of HPC that we have, but are being done at an ultra-scale level of scale that implies supercomputing technology, which is a lot of fancy analyst words for the fundamental question of, does Google have a supercomputer or not, right? What about Amazon? Is that a supercomputer? Does eBay have a supercomputer? Does Yahoo have a supercomputer? If we're going to call those supercomputers, we have to put them somewhere, and they don't meet any of our other HPC definitions. Those go into that ultra-scale internet. And there are an awful lot of nodes. They're a funny one to try to address. So if you don't like it, take them out, but we're counting them and trying to size them. That's what's there. Online games is another interesting one. That's the 15% in green. The servers behind online games have real-time I/O requirements that land them in the HPC category. If I'm playing a game online and I tell my avatar to jump around the corner and fire, and I experience a second and a half lag between when I issue the command and when it does it, and I get blown up in the meantime, my game satisfaction starts to go down. So as much as a lot of the rendering is done on the local machine, there are real-time I/O requirements in the processing of the interactive games. Retail, transportation, some of the other sectors. Oh, media and entertainment is also on the right. We've recategorized that over to the high-performance business computing side. By definition, HPBC is over 95% commercial. There are some exceptions of applications that are government or academia that we would put over there. Like, for example, if the Federal Reserve Bank does HPC, that's a government, but we would really call that an HPBC application. Similarly, if a business school were to buy HPC and it was clearly identifiable as only studying finance applications, we would tend to categorize it there, but there's really very little of that. These different verticalizations are important for various reasons, not only in determining for our clients how big the market opportunities are, but they have very different approaches to HPC, even if you look within the different commercial sectors, especially when it comes to software. This is looking at four of the four largest high-performance technical computing commercial segments, and what their software usage is. The blue sections here are essentially ISV applications. They're purchased, licensed software. And you see the engineering segments in the middle, CAE, CFD, which largely get into auto and aero, but other manufacturing sectors, tend to be dominated by ISV codes. These are the end users who complain about how much they have to pay for software. But when you go into the other areas, you find that it's really a different model. Oil and gas on the lower right, and I would also argue that finance follows this same pattern. Although there are some important ISV applications that you can quickly name, if you really look at the internal workflows, most of the work, the majority of the work, comes on in-house algorithms. They have very high rates of internal algorithmic turnover, and you have to be as much, really more focused on how you're going to solve those internal applications. You do have to pick up the few important ISVs, but you're dominated by in-house applications. And then if you go over to bio and life sciences, it's different again, where you do have a little bit of commercial and in-house, but you're really dominated by this green sector, which is open source. The purple is public, which is even a variety of open source. It's licensed open source for things like Gaussian is the best example of it. So bio and life sciences, you primarily have these open source codes. So you have to take a different approach depending on which of these markets you're trying to address. Now, as much as I took the shot at people complaining about how much they pay for software, I do like to, when I get a chance, have a slide on in defense of software here, because no one ever does this, and I don't mind if people throw food at me. I'm an analyst, and that's part of my job. First, realize that over the last couple decades, really, all of the major architectural shifts that we've seen, whether it's clustering or grid or cloud or multi-core or accelerators, have increasingly shifted the burden of scalability onto the application provider, and to some extent onto the system administrator, to figure out how I'm going to get this stuff to scale, right? It becomes harder and harder to write scalable software. If you compare that to, say, a large-scale SMP, the more the burden of scalability has gone that way. Meanwhile, regarding multi-core, these multiple cores in practice, what I mean is in the way they are actually implemented, is still predominantly where each core is a separate processor. And the way we know that is the memory that gets allocated to these systems, memory per core, is staying essentially constant in deployments, which means memory per node or per socket is going up exponentially. End users treat these cores as separate processing elements. So if you've got this increasing number of cores, to the end user and to the application software, that's like an increasing number of processors. So if you're going to complain, well, it's not fair, you're licensing per core, well, that's how it's being used. Right? Every core is being used as a separate processor today. Also, regarding scalability limitations, I've heard several times over the course of yesterday, well, the application doesn't scale. Sometimes that's true, but not always. Sometimes it's the application, but more often it's the model that doesn't scale. The application could scale, but the model hasn't been done at a high enough degree of fidelity to handle that level of scalability. And even if it did, average scalability of an application, of a typical application run in HPC today, is 38 cores. There's not a lot of benefit for the ISV from a market perspective to be chasing hundreds of thousands of cores of scalability, because no one wants to pay for that, right? There's not a big business model for the ISV to go chasing that. There aren't a lot of users out there who are arguing about how can we pay more for software, right? So, there's not a business model for the ISV there. And then finally, with regard to access for new users, people are saying, well, there isn't software that does this. There is software that does this. But you could give a new user a free computer with free software, and they still have to come up with the model that they're going to put into Abacus, right? You can't buy the model for the digital model for my widget anywhere. Someone has to create that, and it's probably me on the end user side. So all of these are important adoption factors. Now, in as much as I've stuck up for ISVs need to be careful here because open source is coming, right? The fastest growing application in HPC right now is OpenFOAM. Now, it's still a distant second behind Fluent in CFD, but it is the fastest growing application by a lot. And that's because people are ticked off that software costs so much. Okay, now since I'm in manufacturing here, and we're going to have a whole lot of time on manufacturing tomorrow, I will spend a little bit of time on digital manufacturing. I've shown this chart before. I may have even shown this chart here last year, and I won't spend a whole lot of time on it. But this comes from the major digital manufacturing study that we did on the haves and have-nots. This was the first time we conclusively showed the digital technology, the advanced technology gap that separates large companies from small companies. The way to read this is this set of columns, ModSim, HPC. This is people who are doing any type of CAE, any type of modeling or simulation on any size of cluster. It could be a 2-node cluster up to any size of supercomputer. The next one over, ModSim Desktop, this is people who are doing CAE, some type of CAE application, but only on a PC or workstation, not on any level of cluster. The next one over, people who are doing 3D CAD, but no CAE beyond that. And then you've got the 2D CAD or nothing at all in the final column. And then they're grouped by how many employees are in the organization. Well, it's pretty easy to see that the HPC is being done by big companies. And this 55% kind of goes with this 56% up here that's none at all. Or you could slice it the other way and add up the rows instead, which isn't done on this table. But the implication is that 62% of companies with over 10,000 employees, or I should say of manufacturers with over 10,000 employees, are using HPC. But the penetration among companies with under 100 employees is 8%. 95% of U.S. manufacturers have 100 employees or fewer. So that is the size of the opportunity here within HPC. But there are a lot of misconceptions about how we can go market to these people. Now, a lot of this comes out of this major study, which was delivered in full to the clients of that study. It's been a year since we've done that, and we're writing a white paper now that will release some of those findings in general with a white paper, but without the data attached to it. Some of the major misconceptions, I could spend 2 hours on this topic. I'm going to strive not to. I'm looking down at how I'm doing on time. But the first major misconception I'll try to leave you with, if you went all the way back to these revenue charts that we have here, a lot of times you tend to look at it and you see these separated entry-level, mid-range, high-end supercomputer, and it looks like half of the revenue is going to entry-level and mid-range, and it starts to feel like, well, what's so missing about this missing middle? It's a bit of a mirage. That's a transaction-type view. You see entry-level and mid-range systems going out, and you track them as entry-level, mid-range. First of all, the majority of those shipments that are in the entry level and mid-range are add-ons or upgrades to larger systems. So to call it an entry-level or mid-range shipment, it is when it went out, here's 8 nodes, but then it got stapled onto something bigger at the other end. And then of the ones that aren't that, a lot of the other entry-level and mid-range systems that stay as standalones go to end users who also have larger systems. You saw this in Sharon Kalwani's presentation yesterday when he was talking about Aramco. And he said on his chart, just as an example, that Aramco had these 2 big supercomputers, but they also had 40 different smaller systems in various departments, right? So there's 40 entry-level or mid-range servers going out there somewhere, but they're going to Aramco, who is not an entry-level or mid-range user. So if you rearrange your thinking around not what the transaction for this system was, but what's the category of user it's going to, and you restack the users, supercomputer, high-end, mid-range, entry-level, you find that 85% of the revenue in HPC goes to high-end and supercomputing levels of users, and only about 15% go to entry-level, mid-range categories of users. That's due to this advanced technology gap that we talk about, especially in manufacturing, but it's true in oil and gas, it's true in other areas. About the only sector it's not true in is academia. Academia is the exception here. Academia is bipolar. You can quickly name the large academic supercomputing sites and find those, but the converse of that is almost any college or university you walk into, you can find at least some small cluster somewhere doing something. It might be physics, it might be chemistry, it might be astronomy. They might have paid little or nothing for it, but it's there, right? So there are a lot of entry-level academic users out there. They don't add up to a lot of money. So that's the exception to this. Within commercial and government, it's really dominated by high-end and supercomputer. Okay, second misconception, now we're focusing in on manufacturing, is this notion that we should try to bring HPC to all manufacturers. That, if only they could see the benefits, everyone would want to do this. False, false, false. It's an oversimplification that you're going to deliver this benefit to any manufacturer. The most important distinction for whether or not a manufacturer is a possible is a likely adopter of HPC or not is the question, what is your primary differentiation? How do you set yourselves apart from the competition? When you find manufacturers who will identify themselves as the leaders in quality or in R&D for their segment, right? Frank, does this resonate with Simpson Strong-Tie? You're a quality leader for your segment, right? When you find the ones who are quality leaders in their segment, who are trying to out-engineer their competition, those are the ones who are your likely adopters. And it's not all manufacturers. Many manufacturers will differentiate on something else that's reasonable, right? Like good customer service, or they have a fast follower approach. Simpson Strong-Tie is going to generate some new widget that's good on quality, and I'm going to copy it as fast as I can and try to undercut them on price, right? That happens to you guys too. A lot of manufacturers do that, and those aren't the likely ones to adopt HPC. The ones who are trying to get ahead on R&D are the likely adopters, and it's about 40 to 50% of U.S. manufacturers. Those are the ones that you want to be looking for. The other important thing here with regards to marketing to them, this is advice, free advice on the vendor side. One of the more common mistakes I see vendors make in this space is that they will market their entry-level personal supercomputers for the little entry-level HPC user. Entry-level HPC users don't tend to think of themselves as entry-level people buying a little tiny computer. This is the biggest computer they have ever bought, and they are doing something pretty cool and probably something that's unique to their part of the industry. They are leaders in their segment. They think of this as something that's big, not something that's small. You should use language of bigness and leadership when you try to attract this market. Misconception number 3, By the way, missing middle misconception 0 that I didn't mention was calling it missing middle. That's just a bad idea to begin with, but it's a term that's around for various reasons that's on here. And I like the alliteration of missing middle misconception. The final one is better time to market is the effective message that we're going to sell to the would-be adopters. You hear about this as the great benefit, you're going to get to market so much faster. Faster time to market is an eventual benefit of HPC. You do eventually shorten your design cycle time. But first of all, it's not what the would-be adopter has in mind already as a driving need, like I need to get to market faster. Well, we found that does not resonate well across all of the potential would-be adopters. Furthermore, even if you found someone who did think, well, time to market is what I need, adopting HPC for the first time does not get you to market faster. It is a slow, long, painful adoption process. It takes time to create these digital models. It takes time to do the coordination between digital and physical testing. It's going to take a couple years before you're really effectively using HPC in a way that's bringing my product to market. Eventually, once it's adopted, you'll get your stuff out there a lot faster. Instead of picking on Frank again, I'll use a different conversation here I had with the CEO of a small company that makes wiper blades. They're an aftermarket wiper blade provider, which is kind of a perfect example, right, where they're in the auto space, they're in the aftermarket, they're doing engineering, and they flag themselves as a quality leader in their segment. They want to put out high-quality wiper blades. And I was talking to him, and I was asking him about simulation, and he said, this is a conversation I had last year, he said, you know, we've just been talking about this because their lead engineer has been talking to him as the CEO about a new design that they were trying to release, but they were worried that they were going to have trouble with wind lift on the design, which was a term I had never heard until that moment, and yet I kind of immediately got what it was they were talking about, right? I'm on the highway, and you know, the wiper's going to go up. It's got to stay against the windscreen. So we're worried about how we're going to test this. And he said, well, there's really 3 options that they have that they can consider. One is they could try to do a physical wind tunnel analysis. Now, this is a small company. They don't own a wind tunnel. They can't rent a wind tunnel. Chrysler's not going to let them borrow a wind tunnel. It takes you about 5 seconds to cross that off as not practical, okay? So that one's out. The second option is we can try to do a large-scale computer simulation. But first of all, consider in your heads the variables that you're trying to do for wiper blade wind lift simulation with the wiper blade in motion and it's raining or snowing, right, is not the easiest simulation. It's probably a fairly scalable problem. They don't have that computer. They don't have that software. They don't have that digital model. It is certainly possible. I've talked to people who are in the CFD field and they know how they would approach it, right? And they said, sure, we would build the model this way, we'd apply this many processors, but it's not quick. Right? It would take them a while to get to that. And it's not cheap either. Option 3 is they can rent a car from Hertz, put a physical mock-up of the wiper blade on the car, and go out onto the highway at 80 miles an hour with a clipboard and see what happens. Now, they can't make it rain and they can't make it snow, but if he really needs to test it in the snow, he'll send the wiper blades to his guy in New Zealand and tell him to go around in the snow. And the whole thing is done in 4 weeks and didn't cost that much, right? Now, I'm going to come back to the question, are you going to approach this guy with a time-to-market argument and say, I'm going to get you to market so much faster with HPC? Not for your first iteration, you're not, right? Eventually, maybe, but not right away. It's a long, painful process to adopt. Now, what would get you there? What would get him there and what would get 90% of the potential adopters of this there is a quality argument. The number one identified benefit that resonated across all of the potential groups is quality. If you can make the argument that the HPC will give you a higher quality wiper blade, fewer defects, better design, right? That's what they're looking for anyway. You've already identified them as someone who wants to be a quality leader. If you're a vendor trying to market to this space, you should use the quality message every time. Okay, I skip that slide and just go right to this. There are so many of these missing middle initiatives in the market, and I've personally been involved in a lot of them. I couldn't help myself. In September, I put out a report card of what I felt the progress was of all these things. The Alliance for High Performance Digital Manufacturing has done the most to date in terms of synthesizing a lot of the discussion in the industry, but in terms of future outlook, I see a lot more of the benefit coming from things like the NCMS initiatives. These are the grades as I gave them in September. Progress to date since then probably has to be upgraded to at least a B+, maybe an A- for the SIG meetings, and they seem to have a lot of momentum there. There's a lot of good stuff going on with those SIGs and that PIC strategy. However, the America Competes Act still hasn't done anything. The language in the America Competes Act of 2011 was spot on in terms of how it would address the missing middle. The report that would be published by March of 2011, we're still waiting for. And I haven't seen any kinds of actual programmatic initiatives tied to that out of the government. I was fairly cruel to the endemic program out of the United States Council on Competitiveness, mostly because I felt like it didn't do the job of addressing people who've never adopted before. I felt like it had done a better job of taking people who've adopted some HPC already and helping them to get to a new level of scale. Merle Giles, who is on my panel tomorrow, has taken exception to my views here, and I'll give him a shot back at me in a public forum tomorrow. The vendors themselves have a lot of mercenary motivation to go after this, and a lot of their own marketing initiatives, like what we've seen from Intel, HP, to a lesser extent Dell, have been fairly effective in starting to reach out there, or could show a possibility of being effective as they start to reach out. It's really got to be some of the larger companies, though, who have the ability to try to reach some of these markets. I like some of what I'm seeing there going forward. Okay, leaving missing middle for a second. How am I on time? Okay, I'm going to make it. Important HPC trends for 2012. As of May 2011, about 2/3 of HPC users were at least testing accelerators of some sort. I think that's probably gone up from there. We're planning to repeat that survey again this May in another 2 months. This is dominated by GPUs. 90% of people evaluating accelerators in this time frame were evaluating NVIDIA GPUs. They might have also been evaluating something else, but 90% on NVIDIA GPUs here. The interesting battle here is going to be NVIDIA versus Intel many integrated core as this comes out later this year, especially with the new Kepler GPUs coming out from NVIDIA. We are heading into a heterogeneous future with HPC. This is something where we're overcoming a lot of the barriers around accelerators that have held them back for so many years, and we're going to see more and more of it. Storage, despite what I said earlier about the weakness in 2011 because of the supply chain, that was a supply side problem. From the demand side, storage is still going to be the fastest growing product sector, and that's driven by big data and many other things. The Lustre roadmap stabilizing for HPC, I think, is one of the most, I had already flagged this as one of my most important things that happened in 2011. A lot of the open file system groups, initiatives like EOFS and OpenSFS were very important here. WAM Cloud's role is very important here, providing multi-vendor support and roadmaps for Lustre. That's really stabilized a great deal. InfiniBand still is strong as an HPTC clustering system interconnect, but has not shown the ability to grow much in other areas yet, and has kind of reached the asymptote of how much adoption you're going to see of InfiniBand versus Ethernet as a preferred system interconnect. There are some areas that like Ethernet, some that like InfiniBand, and that hasn't been changing much. If InfiniBand is going to continue to grow, they're either going to have to find new markets to expand into or new locales, like InfiniBand as a storage interconnect is probably the greatest possibility if InfiniBand is going to continue to grow. I mentioned finance and the growth there. Important to look at this. The application that gets talked about the most is high-frequency trading. It is neither the largest nor the fastest growing nor the most interesting segment to look at. I almost get bored talking about high-frequency trading. Latency isn't 0 yet, so we're still not satisfied. I get it. You can go to the finance conferences, and that's pretty much all they talk about. The much more interesting segment is risk management. It's larger, it's faster growing. It is an interesting segment to look at. How are they going to manage it? And regulation is coming down on risk management like God's own lightning. It is a big problem for finance to figure out how are they going to cope with increasing regulation in the U.S., in Europe, around the world in terms of how they're managing risk, partially as a result of all the economic crises we went through. And it's not an easy problem. Facilities, I tipped off with the trivia card earlier. Facilities continues to increase as a share of budget. This used to be tabbed more often as a not-in-budget item. Someone paid for power, but it's not me. More often, it's coming in budget. More often, it's going up in cost. It's sucking up more of the HPC budget. This is important because in as much as it's not part of the total spending, that earlier chart I put up, another way to look at HPC spending is to look at total budget, which would add to the $25 billion we already had on there. Total budgets are more like $45 billion because you have internally budgeted items like facilities and staffing. And there are certain vendor solutions where you can say, well, we can save you facilities costs or we can save you staffing costs, which has the effect of moving some of that internally spent items into the total available market for your product. Memory usage is growing with multi-core. I already talked about that a little bit. Memory per core stays constant. Memory per node, per socket goes up exponentially. We might be reaching an asymptote with that and just have our newest site census data in on this now. We're cleaning the data at present, so I haven't seen what the most recent year's trend is on this, but we might start flattening out at 32 gigs per node as a practical limit of what we see, or sorry, 32 gigabytes per core as a practical limit of what we see people starting to configure. On the services side, we see programming services in particular had a big leap on the services side. We also saw an increase on how much people are spending on internal application development. This is as people are dealing with some of those architectural shifts that I mentioned before. Cloud, on the other hand, is only 3% of spending and flat there. It's, in fact, down in 2011 from what it was in 2010. It had been as high as 4%. That doesn't mean there's no market for cloud. There is a market out there for cloud, but it's not this huge segment for HPC because there's so many barriers to cloud. Not only security, which is the one that gets talked about the most, the biggest problem for HPC is getting data in and out. That is the #1 barrier for HPC applications and cloud computing. Windows share flattened after years of growth. In fact, it's starting to decline. That's a lot due on Microsoft's end. They've kind of subsumed their HPC strategy underneath cloud, and you don't see nearly as much HPC focus. A lot of their HPC people have left. And then finally, the last one that I'll spend a little bit more time on is big data. I was delighted that Eng Lim brought it up just before I did. I was kind of surprised it didn't get mentioned at all yesterday. Big data is going to be the most significant present opportunity for growth for HPC vendors this year, next year. It is a growing trend and I don't even like calling it a set of applications, big data. It's more that big data is the trend and it affects a set of applications. And it's a lot of different areas that are going into it. But overall, what we're talking about is there's an increase in the creation of data and the availability or access of data that's starting to stress people out a little bit. And because what connects these different areas is the organizational desire to connect, I've got all this data, to I'd like to make a better decision based on the intelligence that in theory is buried in all of this data. Those are the big data types of applications we're seeing. There are all kinds of different areas. Enterprise analytics gets talked about the most. Big data is not a one-to-one correspondence with Hadoop, right? Hadoop is one particular application for one particular type of big data problem, but there's other stuff beyond that. Research analytics, real-time analytics, complex event processing, data mining, visualization are all in here. There are different types of big data problems. First of all, it's important to realize that, and this will go back to Englam's presentation also, where he showed here's all these petabytes and this is big data. That's big data at the top end, but the big in big data is like the high in high performance computing. It is a relative term, not an absolute number of terabytes or an absolute number of IOPS. An entry-level user who's ingesting 10 times more data this year than they were last year is dealing with a big data problem, even if that's measured in terabytes, not petabytes, right? It's relative to what my organization has the ability to cope with or what we've coped with before. And there are different types of big data bottlenecks. Sometimes it's large files, sometimes it's many files, sometimes it's concurrent access to files, sometimes it's the rate of ingest, sometimes it's because I have to store my files for 20 years, and sometimes it's because the data becomes useless in seconds or milliseconds, right? And you have to compute something within the very short lifespan of the data. The different types of big data bottlenecks imply different needs for technologies that have been nascent in the HPC space that can be applied to these big data applications, whether or not the big data organization, big data using organization in question thinks of itself as an HPC user. I had a good time attending Predictive Analytics World for 2 days. I saw enormous potential application for high-performance computing, and not a single user who would identify themselves as an HPC user. This is the important approach, possible approach for HPC companies. There is the great ability for you to sell your technology into these big data application types, but it's going to require an understanding of what these applications are, what the problems are, without oversimplification, and not going in and saying, well, this has all been solved in HPC, we've done this, right? You've got to understand the problem, but the technology can be applied. We are doing a special study on this, or I should say have done. We haven't released yet, but I'm sitting on all of the data from this questionnaire, right? So those are the questions that we had people answer on big data, the types of opportunities, the satisfaction gap. What we say there is we ask people, what's really important as you're evaluating interconnects, or as you're evaluating storage, or as you're evaluating compute or cloud. And then we ask how satisfied they are with the available solutions, and get to look at where are the gaps. What are the things that are marked as important, but people aren't saying they're satisfied. And the important thing with this is, for a respondent panel, obviously we leverage our existing partnerships to talk to HPC users, but we entered a partnership with Gabriel Consulting. Many of you people might know Dan Olds, who attends many HPC conferences, in order to send the same survey to over 100 non-HPC enterprise respondents. And as part of the analysis, we're comparing how do the HPC responses differ from the non-HPC enterprise responses, and what are the implications for selling big data to HPC users versus to non-HPC users, even when the bottlenecks or problem sets are the same. Working with Intersect360 Research, obviously, people come up and say, how can I get access to this? Well, technology vendors, it's simple. Come talk to me about the different ways that we can work together. It doesn't have to be a major, multi-year advisory contract. We can do strategy sessions for an afternoon. On the end user side in particular, though, we've got some opportunities for how we can get you access to our research and other benefits. Come see me for what that opportunity is. And with -1 minute left, that's my time. Thank you very much.